Hi, this is Ramji Sharma. In this video, we will solve 20 most important questions in business calculus. These questions are not in order according to the progression of the course. I will be jumping over the topics, so you will see these random questions, but eventually I will cover most of the topics that are essential to be successful in a business calculus course. The first question we have here is to find the area between y minus 4x equals 0 and y equals x squared. And then the instruction says round your answer to 2 decimal places. Alright, so it's always a good idea to draw the graph of this function. Actually, there are two functions here. One is given by this equation, and the second is given by this equation. So let's change this first equation into an explicit expression, which is y equals 4x. And you can get this by adding 4x to both sides. And this gives in the form of y equals f of x. And let's call it f1 of x. Similarly, the second equation is already in the explicit form, so I'm just going to copy that down here, and that's going to be f2 of x, which is of course y in this case, and that's going to be x squared. Now we're going to draw these two functions on this xy coordinate here. You can use a calculator if you have a graphing calculator. If you don't have a graphing calculator, you can also draw these types of simple graphs using the point plotting method. I'm going to use a calculator here. So I have this TI-83 Plus calculator, and let's turn this on. Okay, so this is turned on now. Now let's enter the first equation, y equals 4x. So that's going to be the y equals editor here, and so let's see, y equals 4x, so 4 times x. That's our y1, or in this case f of 1 x, and y2 or f2 of x is x squared, so that's going to be x to the power 2. Okay, now we can graph these functions. The first one is y equals 4x, and the second one is y equals x squared. We want to see a little bit to the right side, or a little bit above this range here. So let me go and change the window. So I think the x coordinates are good, but the y, I'm going to change this y min into -5 and y max into, let's do it into 15, and then graph it again. So well, a little bit further more, so I'm going to change the y max into 25 and see what happens. Alright, so this is the graph that we get when we plot these two functions together. What we're looking at is, let me just copy this graph over here, and then we can talk about what we're trying to do with this graph. So this is one of the graphs, and the other graph, maybe I can change the ink. So let's just do that, and that's the second graph. So this is y equals 4x, and back to the black color here, that's going to be y equals x squared. So what we're looking for is the area that is bounded between the curves. Now the formula for finding the area between the curve is, let's just use a different color for that formula thing. So if f1 of x is greater than or equals to f2 of x, and both are greater or equals to 0, meaning they are positive, and one of them is on top of the other, then the area between the curves, or the graph of these functions, in other words, is integral, and then I forgot to write the interval here. So this happens in a closed interval a comma b, that is already given there in the statement. Then the area between these curves is going to be the integral from a to b, and then since f1 is greater than f2, so we're going to subtract f2 from f1, and I can simply write f1 and f2 without explicitly writing x and then dx, which of course means f1 of x and f2 of x. This is f2 of x and then dx. So that's the formula. So in our case, the one that is on the top is y equals 4x, so I'm going to call it by f1, which I've already written here without knowing that this would be on the top. So that was just a coincidence, but you can decide it later. And this is f2. So our area is going to be integral, and our a and b, so these are the points. So down here the x values, this is a, this is b, because this is where these two functions intersect each other. So we gotta find these values, and I'm gonna do that in just a second. So I'm just gonna write this as a and b, and then f1 of x is gonna be 4x minus f2 of x is gonna be x squared, and then we have a dx. So how do we find these a and b? Well, to find these a and b, you have to solve these two equations, because these are the point of intersections, and that's to find the point of intersections between the two functions or two curves, you have to solve these two equations representing the curves. So the first equation is y equals 4x right here, and the second equation is y equals x squared. So if we equate these two equations, because the left side is y in both cases, we can get 4x equals x squared. And then we can get the values of x from this equation. To solve this equation, do not cancel x from both sides, because x could be 0 and you cannot cancel 0 from both sides. So the safest way would be to move this x squared to the left by subtracting x squared from both sides. So this is going to give you 4x minus x squared equals 0. And now factoring the common factor out, which is x in this case, we have 4 minus x equals 0. And using the zero product principle, we have either x equals 0 or 4 minus x equals 0. And from the second equation, if you add x to both sides, then 4 equals x. So we have two values of x. One is x equals 0 and the other is x equals 4. 0 is on the left side, so this is already x equals 0, which is pretty obvious from the graph itself, but the other one is not obvious, and that's the reason why we had to find this using this method, and that's going to be 4. Now I can replace a and b by their values. So it's going to be integral from 0 to 4, and then we have 4x minus x squared dx. Now we got to evaluate this integral and then plug these limits using this definite integral rule. So the integral of 4x is 4x squared over 2 minus the integral of x squared is x cubed over 3, and we're going to put this brackets outside, and this lower limit is going to go down here on the right hand bottom corner, and the 4, the upper limit, is going to be on the top. And because of this space issue, I'm going to move this up here. So now I'm going to replace x with the upper limit and subtract the other part, which is obtained by replacing x with the lower limit. So it's going to be 4 times the value of x is 4, because that's the upper limit, and then there is a square, so 4x squared over 2. I should have already canceled the 4 and 2 and written this as 2, so let's just do that. So that's a 2 here, so I think I can erase this 4 from here. So that's a 2, and then I have times, the parenthesis means times basically, x squared is 4 squared minus, now I'm going to replace x with 4 again, so that's going to be 4 cubed over 3, and then minus, the rest are going to be zeros, because when you replace x with 0, that's going to be 0 minus, of course another minus will give us a plus, but that's not important because that last term is again going to be 0. So those two last terms will not contribute anything to the solution. So eventually this is going to be 4 times 4, which is a 16 times 2, which is a 32, minus this is a 64 divided by 3, and we can use a calculator or do it by hand. Let's just use a calculator here. So we have, let's just clean this, 32 minus 64 divided by 3, and that's going to give us 10.66. So to the 2 decimal places, that's going to be 10.67 is our final answer. Alright, our next question, again these questions are randomly selected, so the topics are not in a continuous progression of the course, so you'll see these random questions from all the places. So this one is about the business application of derivative. So the question says the total profit P of X in thousands of dollars from the sale of X items is approximated by P of X equals x cubed over 3 minus 11x squared over 2 plus 28x, where x is greater than 0, and x, remember, is the items, the number of items rather, that is produced, and we got to find the number of items that must be sold to maximize the profit. Now if you notice this function right here, it's a cubic function, which means it's an increasing function over the time. And what that means is you might be thinking, okay, the more items we produce, the more profit it will be, but that's not how it works, because let's see if I can, because the idea here is not to lose the money. So if you look at the graph of this function in a calculator, that's how it looks. And this is the value of x. So you might think that the more you produce, the more profit you get, but that's but again, that also going to cost you more, because the more production means more cost. So you want to produce the least amount of items and get the maximum profit. So you're looking at the least amount, meaning the smallest value of x, that will give us the maximum profit, and that's basically something we're trying to find here, and that's going to be our relative maximum. So because this thing, there is no global maximum here, because the domain of this function is 0 to infinity, so that's the domain, so we can't find the global maximum here. Anyway, that could be a little bit outside the context of this problem, but I just wanted to mention that so that you're clear on this one. Alright, so what we do is use the derivative, and probably we can use the second derivative test to find the maximum, in this case the relative maximum. So let's find the first derivative of this function, which is p prime of x. I'm using the prime notation here. So that's going to be the derivative of the right hand side, and we have the first term as x cubed over 3, and that's going to be 3x squared over 3. Now remember, I'm using the power rule. Minus 11x squared over 2 is going to be 2 times 11 times x to the power 2 minus 1, which is 1, divided by 2, and plus 28. Okay, now after canceling these common factors, we have x squared minus 11x plus 28, and that's the first derivative. Now we got to find the critical numbers. So in order to do that, we have to set this to 0 and solve this equation. Now this is a quadratic, so you can use a quadratic formula, but if you know a little bit of trinomial factoring or the FOIL method, then you can do that. Now the factoring is not part of this video, so if you are looking some more help in factoring, please look at my other videos. Here I'm just gonna factor it, assuming that you already know how to factor. So 28 means 7 times 4, and 7 plus 4 is 11, so we can get x minus 7 and x minus 4 equals 0. Now using the zero product principle, I have x minus 7 equals 0, which gives me x equals 7, and x minus 4 equals 0, and of course adding 4 to both sides gives me x equals 4. Now these are the critical numbers, and we're going to plug these critical numbers to the second derivative, because I'm using the second derivative test here. So let's do the p double prime of x, which means the second derivative of this function. And now I think I'm going to use the second line here because that's the one that is simplified. So this is the first derivative after simplification. So the derivative of that derivative, which is the second derivative, is going to be 2x minus 11. And now we're going to use the second derivative test. Now the second derivative test is the happy face and the sad face. The happy face is the minimum, the sad face is the maximum. So that means if the second derivative is positive, then you have a local minimum or the relative minimum, and if the second derivative is negative, then you have a local maximum. So like that. So let's plug these numbers, the critical numbers, into the second derivative function. So p double prime of 7 is going to become 2 times 7 minus 11, and that's going to be 14 minus 11, and 14 minus 11 is a 3. So that's the place for a local min, so, or the minimum. And that's not what we are looking for, because we're looking for the maximum profit. So the critical number 7 is not useful for us. I think that's this point here. And then similarly, evaluating the second derivative at the other critical number, which is 4 in this case, is going to give us 2 times 4 minus 11, and that's going to be 8 minus 11, which is a negative 3. And that is a negative. That means we have a sad face, which means it's a maximum. And that's what we're looking for. Now, you have to find, sometimes you have to be careful about the language that is used in the question. Here we're finding the number of items. Number of items is x. So our x is going to be 4. That's our answer. All right, let's move on to our third question here, which says, given f of x equals x minus 3 over x plus 5, find the value of f double prime of 0, which means find the second derivative at 0. If you remember the quotient rule, that might be useful here. So the quotient rule is d over dx of u over v. Again, you might use a different notation, maybe the prime notation, doesn't really matter. And the formula for the quotient rule is v squared in the denominator, and then v times u prime minus u times v prime. The v has a little curly top like that. Okay. So in our case here, the top is u, that's u, and the bottom is v. So we're going to find the second derivative, and that can be found after finding the first derivative. So let's find the first derivative. Now, you're not finding f prime of 0 directly. You'll have to find f prime of x, and then eventually the second prime, and then replace x with 0. That's how it works. Okay, so f prime of 0 is going to be v squared, which is x plus 5 squared, and then x plus 5 on the top, according to that formula, v times u prime. So u prime, let's just find u prime and v prime on this side so that we can plug these things back into this one. So u prime, u is x minus 3, so u prime is 1. Similarly, v prime, because v is x plus 5, again v prime is 1, because we're basically differentiating x. The constants will become 0. So this u prime is going to be 1 minus u is x minus 3, and v prime is just 1. Simplifying this, we get x plus 5 after opening these parentheses with the 1 from the right side, minus, and then now here we have to open the parentheses with the minus sign from the left and 1 from the right. So it becomes negative x, and negative is a positive 3. Let's just do the numerator for a while, and then we can add the denominator down there. So it's going to be, we can cancel these two x's, so it's going to be 5 plus 3, which is 8, and then the denominator I have is x plus 5 and then quantity squared. Now we have to find the second derivative of this thing, so f double prime of x is going to be, now this is not a quotient anymore. You can think of this as 8 times x plus 5 to the negative 2. That might be easier for us. So I'm going to use the power rule. So in that case, it's going to be 8 times. So you bring this negative 2 in the front down here, and then subtract 1 from that negative 2. So negative 2 multiplied by 8 times x plus 5 to the power negative 2 minus 1. And that's going to be a negative 16. And the power here is negative 3. So I'm going to write that underneath 16, which is x plus 5 to the 3. And finally, I have to replace x with 0. So f double prime of 0 is going to be negative 16 over 0 plus 5 cubed, and that's going to be negative 16 over 125, because 5 cubed is 125. So that's the answer. But if you want to change it into a decimal, the decimal value is going to be, let's see if we can find the decimal value here. So that's going to be 16 divided by 125. And how much is that? That's going to be 0.128, and if I round it to 2 decimal places, that's going to be 0.13. So eventually I have negative 0.13 as our final answer for this problem. Alright, our next question is to find the smallest value of the relative maxima of the function f of x equals negative 5x squared plus 6x plus 2. To find the relative maxima, we can use the first derivative test or the second derivative test. I'm going to use the second derivative test because I've already mentioned about it in the previous example, so it'll be easier for us. To do that, we have to find the first derivative, and that's going to be f prime of x in the prime notation, and that's the derivative of the right hand side function, which is negative of 5 times 2x to the power 1, which is just x, plus 6. And from here, let's simplify this a little bit. So that's going to be negative 10x plus 6. And we got to find the critical numbers. So to do that, we have to set this equal to 0. So that's going to be 0, and solve this. So we're going to subtract 6 from both sides. So we have a negative 10x equals negative 6. And dividing both sides by negative 10, we get x equals 6 over 10, which is 3 over 5. That's the only critical number we have. Now we're using the second derivative test, so let's find the second derivative, f double prime of x. And that's going to be the derivative of this expression right here. And that's going to be negative 10, because the derivative of x is 1 and the derivative of 6 is 0. So that's going to be negative 10. So we're always going to have a sad face here, regardless of the critical number. So if you plug 3 over 5 in place of x on the right hand side, since there is no x, this thing is independent of the critical value, so it's always negative, which means the critical number x equals 3/5 is going to give us a local maximum or the relative maximum, because sometimes the relative maximum is also called the local maximum depending on the book that you are following. So This is going to be the critical number 3 over 5. But if you look at the question carefully, we're not looking for the critical number unlike the previous example. In this case, we're going to find the smallest value of the relative maxima. So in this case, you have to replace the value of the critical number from here. You have to replace the value of the x in the original function with the critical number. So we're going to find f of 3/5. That's what we're going to find. And that's going to be -5 and then 3/5 squared plus 6 times 3/5 plus 2. And we'll need a calculator to do this. And if you plug these numbers into the calculator, you'll get 3.8. So that's the answer in this case. Again, make sure you plug these numbers correctly into the calculator and get that answer in this case. So again, remember, in the previous example, like this one, let's see if I can go back here. So in this case, we're finding the number of items that must be sold to maximize the profit. So we're basically finding the critical number that gives us the local max. In this one that I just did, we're finding the smallest value of the function. We're not finding the value of x, but we're finding the value of y, meaning value of the function itself. So depending on the wording, you have to be very careful on these types of questions. Well, our next example is to find the instantaneous rate of change for the function f of x equals 3x squared plus 6x at x equals 0. So in this case, we're going to find the derivative of this function and then evaluate that at x equals 0. Alright, so let's go ahead and do the derivative. Now we're going to use the formula for the derivative. We're not using the definition of derivative in this case. So should be pretty quick. F prime of x. I'm using the prime notation most of the times in this video. So f prime of x is the derivative of 3x squared plus 6x, which is going to be 3 times 2 times x to the power 1, which is just x, plus 6 times 1, which is just 6. And that's going to be 3 times 2, which is just 6x plus 6. And then we're finding the derivative, meaning the instantaneous rate of change. That's the derivative at x equals 0. So f prime of 0 is going to be 6 times 0 plus 6, and that's going to be 6 itself. So that is the answer for the instantaneous rate of change of this function. Moving on, the next example is to integrate 9x to the 5 plus 4x to the 4 plus 5 to the power 7 times 45x to the 4 plus 16x cubed dx. So we're going to have to integrate this function, and since this is a product, we'll have to use the method of substitution for this one. So to use the method of substitution, we'll have to identify the u and then the du. Usually the u is the more complicated structure in the expression. So the first one is more complicated than the second one, and the u is going to be the inside of that structure. So u is going to be 9x to the 5 plus 4x to the 4 plus 5. So since this is not a detailed or in-depth lecture on the method of substitution, I'm just randomly selecting questions from all different topics. If you need help in method of substitution, you might want to look at my other videos. In short, to choose u, you have to choose the function whose derivative is the other part. So usually it depends on the combinations of the two parts. In this case, we have two polynomials as the inside function. So when you differentiate a polynomial, you know that a polynomial will lose one power. So this x to the 5 will become x to the 4, and x to the 4 will become x cubed, hoping that you can balance these coefficients. All right, again, I'm not going in depth of the method of substitution. So let's just do the derivative of this expression. So u equals that. When I said derivative, I should probably say the differential instead of the derivative. So du, you can use du dx and then multiply both sides by dx, even though that's kind of not a good idea. So du equals the derivative of this thing times dx. So 9 times 5 is 45, x to the 4 plus 4 times 4 is a 16, x cubed, and then you gotta do the dx part here. So that's how you find the differential of this u on the left side. So this is exactly what we have as the second part of this expression here. So this whole entire expression is going to change into the expression of u. So the integral sign, and then the first part is 9x to the 5 plus 4x to the 4 plus 5. This whole thing is going to become a u, and then we have the power 7 there. So u to the power 7, and then the rest of it is going to become du. Okay, so this looks much simpler than the original expression. We're going to use a power rule here. So the integral of u to the 7 is u to the 8 over 8 plus a constant c, where c is a real number, the constant of integration. And that we can now back substitute. So u originally is 9x to the 5 plus 4x to the 4 plus 5. So we're going to do that here. So it's going to be 9x to the 5 plus 4x to the 4 plus 5 to the power 8 divided by 8 plus a constant c. All right, that's the answer for this integral. Next question is to find the critical number for this following function. We've already found the critical number in two different examples, so this one shouldn't be that hard, but let's do it anyway. All right, the idea of critical number is the value of x where the first derivative equals 0. So let's just find, so go back to the pen here. So we're going to find the first derivative of this function, which is the derivative of 10x squared, that's a 20x, minus the derivative of 7x, which is a 7, plus the derivative of 4, which is a 0. And we're going to set it to 0 and solve this equation for x. To do that, we're going to add 7 to both sides. So we have 20x equals 7, and then x equals 7 over 20 after dividing both sides by 20. And that's it. We can change it into the decimal. So if you use a calculator, you'll see that this is going to become 0.35. And that's the answer. Next. The next question we have is assume x and y are functions of t. Evaluate dy dt from the following. And this is an equation, 5xy minus 12x cubed plus y cubed equals 7, where dx dt is given as 6, x equals 4, and y equals -3. So this requires an implicit differentiation with respect to t. Now remember, x and y are functions of t, so we can differentiate x and y both with respect to t, and they're not going to be 0. We already saw here dx dt is 6, so we gotta find dy dt. So differentiating both sides with respect to t, we get so here we're differentiating 5xy. Now 5 is a constant, so it will stay back. So d dt of 5xy, let's just put d dt in front of everything, minus d dt of 12x cubed plus d dt of y cubed equals d dt of 7. Okay, so 5 is a constant, so it will stay back because it's a coefficient. So we'll say 5, and then this is a product, so we're going to use a product rule. So the product rule is to, let's just see the product rule up here. So uv prime, again the prime notations and the Leibniz notations like d dt, they're interchangeable, so make sure you understand that. So it's going to be uv prime v, it's uv prime plus v times u prime. That's how the product rule works. So in this case, x is u, y is v, so I'm going to leave x as it is, and the derivative of y with respect to t is going to be dy dt, plus, now I'm going to leave the y as it is, and the derivative of x with respect to t is going to be dx dt. Now remember, I've been saying the derivative of x is 1 in the previous examples because I was differentiating with respect to x itself. Now I'm not differentiating with respect to x. I'm differentiating x with respect to t. That's why it's not 1, it's dx dt. And the same thing with y, that's a dy dt. And then, so that completes this part, minus the derivative of 12x cubed with respect to t. 12 being a constant will stay back, and x cubed, again a constant will become a 0 if they're alone, but if they are a coefficient they will stay back. That's how it works. The derivative of x cubed with respect to t. Now this is a chain rule, so the inner function and the outer function type of thing, or you do the u substitution, whichever method you are familiar with. So I'm going to do the derivative of x cubed, which is 3x squared, that's the outer, times the derivative of the inner, and that's going to be x, and the derivative of x is dx dt with respect to t, plus the same idea with the y cubed, so that's going to be 3y squared and then dy dt, equals the derivative of 7, which is pure constant, it's going to be 0. Okay, now we're gonna have to simplify and plug in these given values, and it's gonna be a little bit of work here. So 5 times, I'm gonna multiply 5 inside and also replace the given values. So 5 times the value of x is 4 times dy dt is the quantity we're looking for, so we're just leaving this as it is, plus 5 times y is negative 3, and then dx dt is given as 6, minus 12 times 3. 12 times 3 is 36, so let's just put it into 36, and then the value of x is given as 4, so it's going to be 4 squared, plus in times dx dt is 6, plus 3, y is negative 3 squared, and then dy dt is going to stay back because that's the missing quantity here, equals 0. So if I add the terms containing dy dt, I have a 20 here, and then I have 3 squared, which is a 9, with the negative being squared, that's a positive 9 times 3 is 27. 27 plus 20 is going to be 47 dy dt. And then on the number side, I have negative 5 times 3 is 15 times 6 is 90 minus 36 times 4 squared times 6, and I did it secretly in a calculator, so I think that's gonna be 3456, and that's gonna be 0. So we have this equal to dy dt is going to be 90 plus 3456, which is a 3546. Make sure you check this with the calculator, and then we're going to divide it by the coefficient of dy dt, which is a 47. So we're going to do that, and that, after using the calculator, we get 74.45 after rounding it to 2 decimal places. Alright, next question we have is to find dy dx by implicit differentiation for the following function. And the function is 5x squared plus 3y squared equals 10. So differentiating this function implicitly, meaning differentiating both sides with respect to x in this case. So let's just write that, differentiating both sides with respect to x. We get, what do we get here? So the derivative of 5x squared is going to be 10x, because we're doing it with respect to x, plus the derivative of 3y squared is going to be 6y times dy dx. So whenever you have y, that's going to produce 1 dy dx after using the power rule or whatever other rules that will come into place, equals the derivative of 10 with respect to x is going to be 0, because 10 is a constant. And all we do is solve this equation for dy dx. So let's just subtract 10x from both sides. So we get dy dx, of course the 6y outside, is going to be negative 10x, and dividing both sides by 6y, we got dy dx is going to be negative 10x over 6y, and if we simplify this, this is going to be negative 5x over 3y as our answer. Alright, our next question is to, let's see if I skipped anything. Okay, no. So the next question is to find the derivative of the following function using the chain rule. Okay, so of course this chain rule is suggested, but there is the other rule that is also required here, because this is a product of two functions. So only the chain rule is not going to be sufficient here. You could probably find the derivative of the following function without even mentioning the chain rule. So be careful with that. So in this case, the product rule, let's just write the product rule here. So that's going to be uv prime equals u times v prime plus v times u prime. So this is u and that is v. The v is the whole thing, x squared minus 3 to the power 15. So u prime is going to be 10x, because it's a 5x squared and the derivative of 5x squared is 10x. The v prime is where the chain rule is applied. So v prime is going to be the derivative of the outer function, which is the power 15. That's why you gotta bring the power 15 down in the front, 15, and then you have the inner function as it is, x squared minus 3 to the power 15 minus 1, which is a 14, and then do the derivative of the inner function, which is the derivative of x squared, and that's a 2x, minus the derivative of 3 is 0. And simplifying this, we get 30x times x squared minus 3 to the 4. So that's the v prime. So if you're not familiar with the chain rule or need more help in the chain rule, please look at my other videos, because this video is not about any particular rule. It's just a mixture of several different questions. Okay, so back to this one. F prime of x is going to be uv prime plus vu prime. So let's just start from the second line here. So it's going to be u is 5x squared, and then v prime is going to be 30x times x squared minus 3 to the power 4 plus v is x squared minus 3 to the 15 times u prime is going to be 10x. Okay, that's pretty much it, and we can simplify this and make it look nicer. So we have a common factor of x squared minus 3 to the 4, should be 14. Hold on a second. So that's a 14 here, sorry. So it's going to be x squared minus 3 to the 14, and then I have 5x squared times 30x, which is 150 x cubed, and then we're gonna have one of the x squared minus 3 because I got the 14 of them out, so one is left, times 10x, so that's gonna be 10 x cubed after I multiply this 10x inside the parentheses, minus 3 times 10 is a 30 times x. And simplifying this a little further, we got x squared minus 4, x squared minus 3 rather. So x squared minus 3. So we got x squared minus 3 to the power 14 times 160, because we have 150x cubed and 10x cubed like terms add. So 160x cubed minus 30x. That's our answer. Alright, our next question is to do with the business application problem. So it says the cost in dollars to produce X items of certain product is given by C of X equals 600 minus 900 times 1.3 to the power negative X to the total power of 0.5. Find the marginal cost when 15 quantities are produced. The marginal cost is basically C prime of X, the derivative of the cost function, and that's another name in business. Okay, so all we do is just find the derivative of this function and replace X with 15. But the derivative itself is going to be a little bit of challenging part because we have a chain of functions, so we're going to apply the chain rule again. Let's do that. So C prime of X is going to be, so we're going to do the derivative starting from the outermost function. The outermost is the power 0.5, so we're going to bring the power 0.5 down in the front, so it's going to be 0.5, and then everything inside the parenthesis will stay back, so it's going to be 0.5 minus 1 in the power. So that's the power rule for the outer function. Now inside we're just going to copy whatever is already there, so it's going to be 600 minus 900 times 1.3 to the negative X, so that's not going to change. Now we're going to do the derivative of the inner function. The derivative of the inner function is the derivative of 600, which is a 0, minus the derivative of 900 times 1.3 to the negative X. 900 being a coefficient will stay back, so we're just going to write that. And the derivative of 1.3 to the negative X is going to be the 1.3 to the negative X times natural log of 1.3 that's the outer function, because this is again another chain of functions, times the derivative of the inner function, which is a negative x, and its derivative is -1. So, and then we got to put this external parentheses here. We're using the formula of d over dx of a to the x equals a to the x times natural log of a. And a little further than that, you can also think of d over dx of a to the kx is going to be the chain rule, so it's going to be a to the kx times natural log of a times k. So here k is a -1, that's why the -1 is appearing there. So these two formulas might help you if you are not familiar with the exponential function. Of course, remember we have d over dx of the natural exponential e to the x is going to be e to the x. That's not going to change. There is no logarithmic function involved, because the logarithmic part involved, because natural log of e is 1. Anyways, so this is the derivative, and all we're doing after this is simplifying this and then plugging the value of x given here as 15. So it's going to be a little bit of work. So we have 0.5, and then we have -900, and then we have a -1. So these things will all multiply together, so two negatives will become a positive, and 900 times 0.5 is the half of 900, which is a 450. So I did it on my head. You can use a calculator if you want. Times, so I'm doing the second part, which is just one expression here. So let's move that to the front. So it's going to be natural log of 1.3 times 1.3 to the -x. And then this first part is going to have a negative power, so we're going to move it underneath that expression. So it's going to be 600 minus 900, 1.3 to the power -x to the entire power of 0.5 minus 1 is a -0.5, but after moving that underneath, it's going to stay back as positive 0.5. Okay, so this is where we're going to replace x by 15. So c prime of 15 is what we're looking for, and that's going to be 450 natural log of 1.3 times 1.3 to the -15 divided by 600 minus 900 times 1.3 to the power -15 to the entire power of 0.5. So let's do it in a calculator. Okay, so here I have my calculator. So let's see if I can enter these numbers or expressions correctly into this one. So we're going to do the numerator and the denominator separately, just to avoid the errors, and then eventually we're going to divide the top by the bottom. So the numerator is 450, so let's do here. So 450 times, I have a natural log of 1.3 times 1.3 to the power -15. So parenthesis open, 1.5 parenthesis closed to the power parenthesis open -15. Now remember to use this negative at the very bottom, right here. Oops, can't move it any further up. Okay, so we're looking at this negative when I said the -15. Okay, so if there is an error in this expression, we'll see that. Otherwise, we'll get an answer in this one. So let's try that. Okay, so that gave us okay 10. So I think I made a mistake. Instead of putting 1.3, I put 1.5. So let's clear this. Well, let's just invoke it one more time, because I gotta fix that thing there. So sorry about that. So that's a 1.3, not 1.5. That was my bad. Okay, so here we go. So that's the numerator, which is 2.30 6571441. So so let's just do that. So I'm gonna copy that to the numerator here. So it's gonna be 2.30657141. Hopefully I copied that correctly. Now let's do the denominator. So the numerator is 2.306571441. Okay, good. Now the denominator. Denominator is a little bit more challenging. Okay, so we gotta put the parenthesis open, and then 600 minus 900 times parenthesis open 1.3 to the power negative 15 inside the parentheses, so negative 15, and then another parenthesis for that external power of parenthesis open 0.5, and then parenthesis close. Hopefully that will give me the answer. So it's going to be 24.13331785. So let me copy that down here. So this is going to be 24.13331785. I'm copying all the decimal and here, because I mean all the digits after the decimal, because I want to avoid the error. I mean minimize the error. Of course I can't avoid the entire error, but I want to minimize the errors that are produced by truncating or chopping these decimal, or in other words rounding up. So something called the round up error. Okay, so we're gonna divide so we're gonna divide the numerator by the denominator. So it's gonna be 2.306571441 divided by the immediate answer I have here is this. Oops, is that right? Okay, I messed up, so I should have done that. Let's just clear this. So let's do it one more time. 2.306571441. 306571441. Okay, divided by the number we have here is 24.13331785. I hope I entered them correctly. So it's going to be 0.09557. So let's copy that here. So 0.097 0.09, what was it? Hold on a second. 5576. So 095576. So 5576 and a few other things. And rounding up to the two decimal places is going to be 0.10. Okay, so that's the answer for this question. Well, the next question we have here is this piecewise defined function, and we have to find all values of x where the following function is discontinuous. So the function is given as f of x equals x minus 1 if x is less than 1. So that's the first branch. 0 if x is between 1 and 4, that's the second branch, and x minus 2 if x is greater than 4. So there are 3 branches or 3 pieces of this function, and we got to find where this function is discontinuous, meaning where this function has any breaks or holes or infinite discontinuities, any sort of things like that. Of course, you can draw the graph of this function if you have an advanced calculator, but that's not the goal of the process here. So we're just going to look at the boundary points, because each branch itself is continuous, because x minus 1 is a polynomial. I mean, it's a linear function, so it's continuous. 0 is a constant function, so it's continuous. X minus 2 is continuous in its domain. But at the boundaries, where there is a joining, these things may not be continuous. So just a quick recall of what a continuous or the continuity of a function means. So f of x is continuous. CTS means continuous at x equals a, if x equals a, if limit x goes to a, f of x equals f of a. But the limit itself is the left hand limit and the right hand limit. So limit x goes to a minus f of x equals limit x goes to a plus f of x, and that has to be equal to f of a. So these are the 3 things that have to be equal to each other for this function to be continuous. So we're basically checking the continuity at these boundaries, because the rest of the things are not problems here. So at x equals 1, so let's find the left hand limit. Limit x goes to 1 minus, that's the left hand limit of f of x. So when x is on the left side of 1, you're looking at the first branch, so it's going to be 1 minus 1, which is a 0. Similarly, you have limit x goes to 1 plus f of x, which means we're coming towards 1 from the right side, so that means we're looking at the second branch of this function, which is 0 itself. So these two are equal. Now let's do one more thing, which is f at 1. F at 1 is again the second branch, because the equality is in the second branch, so that's going to be 0. So as you see, all 3 quantities are equal, so this function is continuous at x equals 1. So we should not worry about 1, because we're looking at the point of discontinuities. So let's look at the second boundary, which is at x equals 4. So at x equals 4, limit x goes to, well, let's do it in a different place. So at x equals 4, we have the left limit x goes to 4 minus f of x is going to be the first branch, meaning in this case the second branch. It's going to be 0. That's when the function is on the left side. And limit x goes to 4 plus f of x is on the right side of 4, which is x minus 2, and we're replacing x by 4, so that's going to be 4 minus 2, and that's going to be a 2. So as you see, these two things are not equal to each other already, so you don't even need to worry about the value of the function, but I can do that anyway. So f of 4 is going to be the one that has the equality sign. That's the second branch. In this case, that's a 0. So in this case, the left hand limit and the value of the functions are equal, but the right hand limit is not equal to any of those. So this function is discontinuous at x equals 4. So the answer is x equals 4. That's the only place where this function is discontinuous. Alright, moving on, let's look at our next question. Our next question is to integrate 3x cubed minus 6 over x to the power 2 over 5. So this is, even though this is a quotient, we don't have a quotient rule in integration. So we gotta do some other ways to do this. And one way to do it is to distribute or divide this numerator by the denominator. So let's do that. In this case, it's simpler. So we're gonna do 3x to the 3 over x to the 2 over 5 minus 6 over x to the 2 over 5, and then dx. And these powers of x can be combined using these laws of exponents. So 3x to the power 3 minus 2 over 5. You can move the power to the top, minus 6x to the power negative 2 over 5. So the negative is when you move the powers, the variables to the top, and then dx. We haven't integrated this thing yet. We're just doing the algebra part for now. So this is integral of 3x to the power 3 minus 2 over 5, which is 15 minus 2, which is a 13 over 5, I believe. 15 minus 2, 13. Minus 6 x to the power negative 2 over 5, and then dx. Now we can apply the power rule. Remember, the power rule is integral x to the n dx equals x to the n plus 1 over n plus 1 plus a constant c, provided n is not equal to negative 1. So that's the one we're going to use here. In the first case, n is 13 over 5. In the second case, n is negative 2 over 5. So it's going to be 3x to the power 13 over 5 plus 1 over 13 over 5 plus 1 minus, then we have 6 x to the power negative 2 over 5 plus 1 over negative 2 over 5 plus 1 plus a constant c. And after simplifying this, we have 3x to the 13 over 5 plus 1, which is 18 over 5, and then we have 13 over 5 plus 1, 18 over 5 in the denominator. And if you simplify these things, so you have 18 over 5 and then a 3. So if you cancel the common factors, you're going to have 5 over 6, I believe, because 18 and 3 cancel each other. So 5 over 6, and then you have x to the power 18 over 5, and then you have a minus sign there, and 6 is going to be on the top, and the bottom is going to be negative 2/5 plus 1, which is a 3/5, and 3 and 6 cancel, so that's a 2. 2 times 5 is a 10, so it's going to be 10. X to the negative 2/5 plus 1 is 3/5, and of course plus a constant c. That's the answer. Okay, next question is to find the derivative of the following function. And this function is a quotient, so you can use the quotient rule, or you can simplify this and use the regular rule. Either way is fine. So using the quotient rule, it looks like u over v prime equals v squared, and then v times u prime minus u times v prime. Again, you can use the prime notation or the Leibniz notation on the left side, but on the right side the prime notation looks easier to write. So in our case, u is going to be 5x minus 3, so u prime is going to be 5, and v is going to be square root of x, so which is actually x to the 1/2, and then v prime is going to be 1/2 x to the 1/2 minus 1, which is 1/2 x to the negative 1/2, which is 1 over 2 square root of x. Alright, so f prime of x equals v squared, which is square root of x squared, and then v, which is the square root of x, times u prime, which is a 5, so that's a 5, minus u is 5x minus 3 times v prime is 1 over 2 square root of x. And that's the answer if you don't want to simplify it. Let's simplify this a little bit further. So there is this denominator, I mean a fraction. So if you take the common denominator, it's going to be 2 times square root of x times square root of x, which is x times 5. So that's a 10. So let's just write that as a 10x on the top. So 10x minus, on this one I have 5x plus 3 on the top, and then on the bottom I have square root of x squared, which is x times, I have this 2 square root of x coming down here, so there's going to be 2 and then square root of x. So eventually I have 10x minus 5x, which is 5x plus 3 over 2 times x has a power 1 and square root of x has a power 1/2. So if you add them together, we're going to get x to the 3/2. Again, depending on how skillful you are in simplification, you may have this answer or maybe a slightly different variation depending on your taste. Okay, so far we have done 16 questions and I have 4 more questions. Alright, so the next question I have here is to find the mixed partial derivative. So for the function f of x, y equals 5x squared plus 4x to the 4 y cubed plus 2y to the 5, find the value of f sub yx 0 comma negative 3. That's the second order mixed partial derivative of this function. Okay, so we're going to go from left to right when we do the order of these derivatives. So the first thing we're going to do is f sub y, the partial derivative of this function with respect to y at 0 comma negative 3, but that's something we'll replace at the end. So we're going to do with x comma y in the process. So f sub y, x comma y equals to, we're doing this derivative with respect to y, so this term is going to be 0 because it's a constant in terms of y, and then this 4x to the 4 will stay back because it's a coefficient, and then y cubed will be differentiated. So the derivative of y cubed with respect to y is going to be 3y squared. 3 times 4 is a 12, so 12x to the 4 y cubed, I mean y squared rather, because y will lose 1 power, plus, and the second term is, I mean the third term in this case is 2 times 5, which is a 10, y to the power 5 minus 1, which is a 4. So that's the first order partial derivative with respect to y. Now we're going to do this second partial derivative, or the second order partial derivative, but this time we're going to differentiate it with respect to the second variable, which is x. So anything that has x will undergo differentiation, but anything that does not have x or a purely y related term is going to go to 0. So this is going to go to 0 because it's a constant for x. So f sub yx of x comma y is going to be the derivative of the first term, which is 12x to the 4. 4 and 12 is 48 times x to the 4 minus 1, which is a 3, and then y squared will stay back because 12x to the 4y squared can be thought of as 12y squared x to the 4, and this whole thing is a constant. So you're basically differentiating x to the 4, and that's a 4x cubed, but that 4 and 12 multiplied together and then it gave us 48. Okay, so and then the second term is going to go to 0. Now we're going to replace x with 0 and y with a negative 3. So f sub yx at 0 and negative 3 is going to be 48, and then 0 cubed, and then negative 3 to the 2. But then 0 in this term here is going to make the whole entire thing into a 0, and that's the answer. Okay, 3 more questions. So the third last question is to find the limit of this function at x equals -4. The function here is x squared plus 8x plus 16 over x plus 4. While finding the limit, you can apply the direct substitution if that is allowed. If not, we'll have to simplify and do some manipulation before applying the limit. So if you direct substitute, that's going to give us a -4 to the 2 is a 16, minus 8 times 4 is a 32, plus 16 over, in the denominator we have a -4 plus 4. So that's going to give us a 0 over 0 situation. So we're not allowed to do the direct substitution. So what we need to do is factor the numerator, so that if we have a factor of x plus 4 on the numerator, then we can cancel those two factors. So let's do that. So in the notation we have limit x goes to -4, and then on the top I'm going to factor this out. Again, if you are not familiar with factoring process, please look at my other videos. This video is not about factoring, but we're gonna use that concept and factor it without mentioning any further. So it's gonna be x plus 4 in this case, divided by x plus 4. And as you see, x plus 4 is a common factor, so we can factor that out. Cancel the common factor rather. And then we have a limit x goes to -4, and then x plus 4. Now every time we do some simplification, we'll always check if we can do the direct substitution. So in this case, if we direct substitute, it's going to give us a -4 plus 4, and since we don't have a fraction, we're safe, so it's going to be a 0 in this case, and that's the answer. Alright, so let's look at our second last question, which is to integrate 5x minus 4 to the 2 dx. So these questions are randomly selected from all different topics, and so we're jumping over one topic to the other topic because it's a crash course in business calculus. So we're trying to cover everything that is required in this course. Okay, so in this case we have a square, and we don't have a formula directly. Well, we do, but I want to avoid that. So let's just simplify it. So integral of 5x minus 4 to the 2 dx, if we FOIL it, it's going to be 25x squared minus 5 times 4 is 20 times 2 is 40x plus 16. And then dx. So the magic I did here is this little formula, a minus b quantity squared equals a squared minus 2ab plus b squared. If you remember this formula, it's going to save a lot of time. So here a is 5x and b is 4. So a squared is 5x squared, which is 25x squared, minus 2ab is 2 times 5 times 4, which is a 40. Plus b squared is a 4 squared, that's a 16. Now this is a polynomial, so we can integrate it using the sum and difference rule. So it's going to be 25x cubed over 3 minus 40x squared over 2 plus 16x plus a constant. And simplifying this further, we have 25x cubed over 3 minus 20x squared plus 16x plus a constancy. Okay, let's look at our last question. Our last question is the easiest one. Integrate this bunch of terms here, which is 4x to the 7 plus 8x cubed plus 3 over 5x to the 6 plus e to the x plus 3 to the x dx. So we're just distributing this integral inside and then integrate each and every term. And remember the formula for integration of x to the n dx is going to be x to the n plus 1 over n plus 1 plus a constant c if n is not equal to -1, and the integral of e to the x is going to be e to the x plus a constant c, and integral of a to the x is going to be a to the x over natural log of a plus a constant c. So these are the basic formulas for integral, so make sure you remember them. Okay, so here we're going to do 4x to the 7. Of course 4 is a constant, so it will stay back. So 4 times x to the 7 plus 1, 8 over 8, plus 8x cubed. 8 is going to stay back, so 8x to the 3 plus 1, 4 over 4, plus, now this thing right here, you have to manipulate this a little bit, so it's going to be 3 over 5, and then you have to move x to the top, so it's going to be x to the -6, because we don't have a power, we don't have a rule that has to do with this power in the denominator. You have to bring it up to the numerator. Negative power is fine as long as the power is not -1. So we're going to do 3 over 5 and add 1 to the -6, so it's going to be x to the -5 over -5, plus the integral of e to the x is going to be e to the x, no change, plus the integral of 3 to the x is 3 to the x over natural log of 3 plus a constant c. This is the last formula here. Okay, so after simplifying this, we have 1/2 x to the 8 plus 2x to the 4, and then we have 3 over 25 with a minus sign, so 3 over 25, and then the power of x is negative, so I'm going to move it underneath 3, so sorry, so it should be a positive 5 now, so 3 over 25 x to the 5, and then plus e to the x plus 3 to the x over natural log of 3 plus a constant c. Alright, so we did a lot of problems in this video. We did about 20 problems, and I hope you learned something from these examples. You can rewind this video and pause as many times as needed and try to solve these problems on your own. That's all for this video. Thank you for watching. Bye.